So, welcome to this module, and in this particular module we will see how the high pass filter can be designed using the operation amplifier. So, guys, until now what we have seen how you can use operation amplifier for designing the low pass filter. So, and we have also seen what are the passive and active filters. So, when you talk about the low pass active filters, what we have seen, we have to use a amplifier, and in this particular case in the last module what we have seen, we have used the operation amplifier. Now, how we can design high pass active filter using operation amplifier, that is the thing that we have to learn in this particular module, alright. So, if you see the screen, what you can find is that a high pass filter is a filter that significantly attenuates. So, if you can please show the screen please. A high pass filter is a filter that significantly attenuates or rejects all the frequencies below Fc and passes all frequencies above Fc. Okay. So, what is that filter? A filter is that all the frequencies below Fc it will reject, while above Fc it will pass. So, what is that Fc? Fc is our critical frequency. We have seen in the last lecture what is Fc. Fc is nothing but our critical frequency. So, now when we here the main thing that you will see which is different than the low pass filter is the placement of the R and C, right. In the low pass filter there was the resistance was here, resistor was here, and capacitor was in this particular place, correct. In high pass filter we have capacitor followed by the resistors, The pass band of a high pass filter is all frequencies above critical frequency. So, now let us see what exactly a high pass filter is. So, if you see this particular plot, what we find is that it will allow frequencies which are above critical frequencies. In the last module what we have seen low pass filter, that means the frequency below critical frequencies were allowed to pass, right, band of frequencies below critical frequencies were allowed to pass, while in case of high pass filter the band of frequencies above critical frequencies are allowed to pass, right. So, this is the ideal response. As you can see, there is again a brick wall, it is an ideal response. Exactly at Fc it will stop the frequencies, right. Here this is a stop band and this is a pass band, this is a stop band, it is a pass band, right. So, now if I draw a gain versus frequency, what I see is that I will have a plot like this. I will have a plot which is exactly opposite to that of a low pass filter, Now, what is the next? Again I can see the response of single pole. You now know what is single pole. We have discussed in the last module what does single pole means and what you mean by first order, what you mean by second order low pass filters, and now we will see the high pass filters. Here single pole RC filter, there is only one R, one C, you can generate a voltage across this resistor, and then you can see that because it is single pole RC or first order RC filter, it has a roll off rate of 20 dB per decade. It is a roll off rate of 20 dB per decade. If I have second order second order high pass filter, then my roll off rate will be 40 dB. Third order high pass filter, my roll off rate would be 60 dB. So, as you increase the order, you reach your ideal response, correct. Now, the critical frequency of a high pass RC filter occurs when what is the formula? Formula is similar to your low pass filter, that is Fc equals to 1 upon 2 pi RC, right. Same formula we have used for the low pass filter as well, right. So, this is the critical frequency formula for active filter for the high pass filter, and here Xc equals to R can be calculated using the formula which is here, which is given here. Ideally the response rises abruptly at the critical frequency Fl. So, here critical frequency would be Fl. Now, if I talk about active filter, right, active filter first order high pass. So, three things, first is first order because 1 R 1 C, then high pass because it will allow the high frequency to pass, frequency which is above my critical frequency, right, frequency which is greater than my critical frequency, it will allow to pass, frequency which are less than my critical frequency, it will stop, right. So, this will be my stop band, this will be my pass band, correct. Then we have active filter because we are using a non inverting amplifier, we are using a non inverting amplifier. So, this we will see in the experiment part also, how we can design the inverting amplifier, how we can design a non inverting amplifier, how we can design integrator, how we can design differentiator, what is the role of ground, what is the role of loading effect, we will see everything in the experimental section as well, alright. So, if you see back screen, what you will see is like the previous active low pass filter, the simplest form of active low high pass filter is to connect a standard inverting or non inverting operation amplifier to basic RC high pass active filter, high pass passive filter. That means that we have this passive filter and you are connecting this passive filter to either inverting or non inverting or unity gain amplifier, right. If here the gain is 1, but if I want a higher gain, I can use inverting or non inverting amplifier. Here we are using unity gain amplifier, right. So, technically there is no such thing as an high active high pass filter, unlike passive high pass filter which have an infinite frequency response, the maximum pass band frequency response of active high pass filter is limited by open loop characteristics, right. We have seen, or bandwidth or op amp being used. So, what kind of high pass active filter we can design, and what will be the voltage gain in case of active high pass filters. So, right, what we have seen now is that we are using active high pass filter with unity gain amplifier, right, with unity gain amplifier here. But what if I want to amplify the signal, then I need to use the inverting or non inverting amplifier. Here I am using a non inverting amplifier, as you can see the output of the filter is fed to the non inverting terminal of the operation amplifier, is not it correct. So, a first order active high pass filter, as its name implies attenuates low frequencies and passes high frequency signal, correct. It consists simply of a passive filter section followed by a non inverting operation amplifier. We have seen here this is a passive filter, right, and this is our non inverting op amp. The frequency response of the circuit is same of the passive filter, frequency response is same, the formula would be f c equals to 1 upon 2 pi r c, right, except that the amplitude of the signal is increased by the gain of the amplifier. Why? Because here we have a non inverting amplifier, my DC gain would be nothing but 1 plus R2 by R1, right. So, we can change the gain, and that is why the symbolic representation of the signal at the input and the output, we can see that the output is magnified version or amplified version of the input, correct. So, what we have seen, the frequency response of the circuit is same as of passive filter, however, the amplitude of signal is increased by the gain of the amplifier. And for a non inverting amplifier, the pass band voltage gain is 1 plus R2 by R1, we already talked about it, and that is the same as for the low pass filter. The first order high pass filter consists of passive filter followed by non inverting amplifier. It is shown here, the frequency response of the circuit is same as that of passive filter, right. For in non inverting amplifier circuit, the voltage gain for the filter is function of feedback resistor R2 divided by R1, voltage gain here is AF f by fc of under root of 1 plus f by fc whole square, right. We have seen what is AF, AF is nothing but pass band gain, formula is same, which is same formula of a low pass filter. The only difference here is now we are passing the signal through the capacitor and then it feds to the resistor. Earlier the signal were passing through the resistor and the capacitor was placed here in the low pass filter, right. That is only one difference which you will find in low pass and high pass active filters. These are very basic circuits of the operation amplifier. So, there should be no problem in understanding this kind of circuits, super easy, right, super easy. Fc is the cutoff frequency in hertz that we have seen earlier also. So, in this case if I use this particular formula and if I see that at very low frequencies, what will happen? At very low frequencies my V out by V in will be extremely less than AF, but at f equals to FC I will have the similar value 0.707, but at very high frequency my value would be equal to AF. So, then the active filter, so what does that mean? From the equation that we have found, what we mean is that in the case of active filter, it has a gain AF that increases from 0 hertz to low frequency cutoff point, right. If you see the screen, then you will understand better that the active filter has a gain AF that increases from 0 hertz to low frequency cutoff point, and FC has a 20 dB decade, right, 20 decibel per decade. If I have second order, I will have 40 dB per decade, third order 60 dB per decade. At FC equals to 0.707 AF, this one, right, and after FC all frequencies are pass band frequencies, the filter has a constant gain of AF, right. So, see that means if I start plotting the graph, what I will see is I will see that okay, it has plot like this, right, where this is my FC. All frequencies above cutoff frequency that will be passed, all frequencies below this cutoff frequency will be stopped. However, there is a roll off rate like I said, and this is a single order, then roll off rate is of 20 dB per decade, right. Okay. So, if I take an example, so if calculate the cutoff frequency or breakpoint frequency FC, okay. So, FC formula we can directly write 1 upon 2 pi RC or 1 by 2 pi RC for a simple passive high pass filter consisting of capacitor C equals to 1 microfarad, okay. So, and connected in series with 1 kilo ohm resistor. I have value of R, I have value of C, so I can find the value of FC, right. So, my critical frequency or cutoff frequency FC is nothing but 1 by 2 pi RC, which is equivalent to 159.15 hertz, is equivalent to 159.15 hertz. So, this is how I can calculate the cutoff frequency of the high pass filter. Let us take another example. Design, now you see you have to design, okay, design an non-inverting active high pass filter such that gain equals to 2, lower cutoff frequency or corner frequency is 2 kilohertz and capacitance of 79.5 nanofarad, alright. These three things are there. So, first is gain equals to 2. So, I have gain equal to 2, right. Non-inverting amplifier, my gain is 1 plus R2 by R1 is given as 2. So, R2 by R1 will be equal to 1, right, or R2 will be equal to R1, very easy, right. Now, frequency is given, C is given. So, I can find R, F equals to or Fc equals to 1 upon 2 pi RC, R is given, Fc is given, sorry, here what is given, C is given, Fc is given, then R equals to, R will be 1 upon 2 pi Fc into C. I substitute the value and what I will have? I will have value of R. Now, I know the value of R, I know that what should be R2 and R1, R2 and R1 should be equal to 1 or R2 should be equal to R1. So, I can design R2 R1, I know the capacitor, I found the value of resistors, thus I can design this particular circuit which is shown here, which is shown at the bottom right, which is this particular circuit, right. I can design this circuit given this particular values, which is the value of a gain, value of the cutoff corner frequency and the value of the capacitance. So, if I am given this values and if I am if I have to find the value, if I have to design the circuit, that is my high pass active filter, I can design by using this particular values, or if I am given a circuit, I can design my high pass filter, both the ways I can do it. So, let us see one more example. Calculate cutoff frequency and the pass band gain of filter shown in the figure. So, suppose you are given this figure, right. So, what is this figure? This is nothing but my high pass active filter, right, high pass active filter. Now, what I have to find? I have to find the cutoff frequency, that means I have to find Fc, right. Fc is 1 upon 2 pi Rc, okay. Now, R1 is given, R2 is given, C is given, right. So, I can write down 1 by 2 pi into 10k into 0.1 microfarad. This will be nothing but 159.15 hertz, right. So, Fc is nothing but 159.15 hertz, correct. So, now I know what is my critical frequency, I can calculate my critical frequency using this particular formula. What is the next question? Next question is for a pass band gain of 10, that is I have a gain of 10, right. So, here it will be R2 by R1 equals to 10, right. Why? Because it is an inverting amplifier, it is a inverting amplifier. So, R2 by R1 equals to 10 or R2 would be equal to 10 times R1, right. So, if I take R1 equals to 10, R2 would be 100 kilo ohm. Easy, super easy, right, super easy to design or to calculate the cutoff frequency given the circuit, right. So, now we have seen if we are given the value we can design the circuit, if the circuit is there we can find the values, circuit is there we can find the values, right. So, what we have seen in this particular module, what we have seen that we can design an active filter, we can design an active filter using the operational amplifier, and then if you are given a circuit then you can find the values of the resistor, capacitors or frequency, and or if you are given the values you can design the circuit, which is this particular problem, which is the problem in front of you, right. So, now the point is that with the operational amplifier we can design filters, with the operational amplifier we can design filters that can allow a certain band of frequency to pass and certain band of frequency to stop, right. So, we have seen in this particular module high pass filters, we have seen high pass filters. The main difference between high pass and low pass filters that you guys have to remember is that in the high pass filter the capacitor is at the starting and the resistor is next. In the low pass filter we feed the value to resistor and then to capacitor, right. So, the signal goes to the resistor and then it goes to the capacitor, but in the high pass filter it is the opposite of that, alright. So, we have seen low pass, we have seen high pass. Now, in the next module we will see how the band pass filter works, and in the following module we will also see how the band reject filter works. So, that is the main 4 filters that we have talked about, right, low pass, high pass, band pass and band reject, alright. So, let us see in the next class how we can design a band pass filter using an operational amplifier, how we can design a band pass filter using operational amplifier. Till then you solve this kind of questions like what I have shown it to you. There are millions of questions that is available online. Try to solve few more questions and you will get a better idea, right. So, we are starting at the very basic level where you are asked to find the formula of a cutoff frequency, right, where given everything is given. So, there should be no mistake in this, right, or for the given values of resistors or capacitor or critical frequency, how you can design the circuit. So, it is really simple, alright. We are at very basic stage. So, you should not be able to you should not commit any mistake in designing such a simple circuits, alright. Now, one more point that I wanted to tell you is that when sometimes you are asked that design high cut filters, high cut active filters. So, what I have seen that when you are asked high cut active filters, high cut is low pass, right, it is cutting high frequency, it is not high pass. So, when you are given this kind of problem, just read it thoroughly. Is it high cut, is it low cut, is it high pass, is it low pass, what does that mean? Low pass and high cut same, high pass, low cut same, right. So, understand this when you are given a problem, read it thoroughly. When you are asked a question, understand, listen the question carefully, then you respond, alright. Listen carefully everything, then only you respond. That will help you not only in your exams, that will help you also in your interviews, alright. So, I will catch you in the next class, next particular module, and we will see how the op amp circuits can be used as a band pass filter. Till then, you take care.